they start at n equals 1. That's totally fine. Let's go ahead and talk about if that is the same as what we have. Bam, cut, bring it back. So let's write out the first few terms here. When n is equal to 0, I have negative. Okay, so they have the negative outside, so let's leave the negative outside, if you guys don't mind. Do you mind? No? Good. So, now let's not focus on that negative, let's only focus on what's inside here, because they have the negative outside as well. When n is equal to 1, or sorry, 0, they have x squared over 1 plus, when n is equal to 1, they have x to the 4th over 2 plus, here they have x to the, so this is n equals 0, n equals 1, n equals 2. When n is equal to 2, this is x to the 6th over 3 plus, and I'll do one more. When n equals 3, they have x to the 8th over 4. So what we have here is whatever the power is up there, the denominator is half of that. And our very first one is x squared over 1. And then x to the 4th over 2. X to the 6th over 3. But then the whole thing is negative, right? That's what we got by doing it this way. Correct? Okay. Let's see what they have here. Again, ignoring the fact that there's this negative out there because the negatives are both there. So we're just looking at what else. So this guy, so just this is equal to, when n equals 1, I have x squared over 1 plus. When n equals 2, I have, so n equals 1 is the first term for their series. When n equals 2, they have x to the 4th over 2 plus, when n equals 3, x to the 6th over 3 plus dot dot dot. Hey, it's the same exact thing that we got, right? So the only thing that is different is the index changed. They started with 1 instead of 0, and therefore the terms are slightly different. But it's the same exact series. And they're both centered at 0, and right? So if you put this on the free response as your answer, 100% right. If you have this, 100% right. It's the same stuff. Okay? Do you see that? Let me see, substituting. Oh, they had already done ln of 1 plus x, and so they substituted negative x squared in for x for something that they had already found. When they found this, when they found that, they probably started at n equals 1 for some reason, so they're just substituting into something that they already had. Okay, so that's where they're getting that from. Now, Marcus, so let's go back up, and you're saying you want to know where this comes from, in blue or above that?
Above that.
Okay, go for it.
How did you get the summation which you would integrate it? Find what summation ln of 1 minus x squared. So you see the summation in the box in the middle, right? Yeah, how do you get that?
How did I get this from that?
Yeah, well, from the start.
Well, you see where that first line comes from, because
Yeah.
that's something that we just know. Going from this step to this step, I said, okay, I know what that looks like, and it doesn't just have a 1 minus x in the denominator, it has a 1 minus x squared. So let me replace this x, and therefore this x, with an x squared, right?
Mm-hmm.
So you see where this comes from.
Yeah.
But then I said, well, that's not exactly what the derivative is, because there's a negative 2x that's being multiplied by that. So let me multiply this by a negative 2x. Does that make sense?
Yeah.
Well, then the negative 2 can just stay outside, but let me bring the x in because there are already x's there. So x times x to the 2n is x to the 2n plus 1.
Okay, I see that.
Okay, so that's where I got this from. But again, this is the power series representation for f prime of x. I really want the power series representation for f of x. So I needed to anti-differentiate that, which I did here. And I had the plus c, and I solved for that c by plugging in x equals 0 because that zeroed everything out. I have to just let you know. My mother-in-law calls it the